Welcome to College Algebra. In today's video, we're going to be looking at the powerful technique of generating new functions via transformations. Transformations come in three varieties: shifts, stretches, and reflections. We can generate a new function by shifting, either horizontally or vertically. Algebraically, horizontal shifts are associated with changes to the x variable, and vertical shifts are associated with changes to the y variable. In this example, using the square function, the equation of the function is transformed by a horizontal shift h units from y is equal to x squared to y equals x minus h squared. A question that always comes up: why are we subtracting to make the graph move right? The answer is, we're not actually moving the graph. We're moving the axis. The only reason we don't notice this is because we are viewing the graph from the axis. With this in mind, it's understandable why we're subtracting. We have to move the axis left in order to make it appear we're shifting the graph to the right. The algebra for a vertical shift, k units, is exactly the same, with the roles of x and y reversed. The only difference is that at the end of our transformation, to recover the equation in function form, we need to do algebra to re-isolate y. Like shifts, stretches can be either horizontal or vertical. And likewise, horizontal stretches are associated with changes to the x variable, while vertical stretches are associated with changes to the y variable. To stretch a graph horizontally, we compress the x-axis, which is why a stretch corresponds to a division. Similarly, we compress the y-axis to stretch the graph vertically. And again, after transformations on y, we need to do algebra to re-isolate y and recover the function form of the equation. The last type of transformations we'll look at today is reflection, either across the x-axis or across the y-axis. Our example this time is the exponential function, y equals e to the x, a library function we'll examine more carefully later. As seen in an earlier video on symmetry, reflection across the x-axis means changing the sign on y, and reflection across the y-axis means changing the sign on x. As always, after a y transformation, we recover the function form of the equation by doing a little bit of algebra. To unleash the full power of transformations, we need to combine them. For this example, we'll use the inverse of the exponential function, the natural log function. We're going to reflect around the y-axis, shift 1 unit horizontally, and then stretch vertically times 2. Beginning with y equals log x, we reflect around the y-axis by replacing x with negative x. The horizontal shift comes from replacing x with x minus 1. The vertical stretch comes from replacing y with y over 2. Lastly, we express our answer in function form by isolating y. In summary, algebraically, keep in mind that transformations are accomplished by changing x or changing y. We change x to perform a horizontal shift, a horizontal stretch, or a reflection around the y-axis. We change y to perform a vertical shift, a vertical stretch, or a reflection around the x-axis.